C programming language is known as the mother of all programming languages present in the software industry. Anywhere you go for an interview, C programming language is the most basic and very important aspect which the recruiters are looking for. Hello and welcome everyone, I am Ravi from Edureka and today I welcome you all to this tutorial session on C programming. In this tutorial, we shall discuss very important and crucial concepts related to C programming. So, without wasting much time, let us quickly get started with our agenda for today's discussion. We shall begin with a brief introduction of C programming language, where we will learn about the history and importance of C programming language. After that, we shall learn about the installation procedures to be followed to install C programming in your computer system, and after that, we shall discuss the data types and variables which we use in C programming language. Followed by that, we shall discuss the most important concept, which is C tokens. Followed by C tokens, we shall discuss the most important concept in C programming, which is the preprocessor directives, without which no program can be executed in C. Followed by preprocessor directives, we shall learn to execute our first C program in C editor. Later, we shall discuss the control statements used in C programming, along with the loops used, and followed by that, we shall look into the pointers used in C programming. Followed by pointers, we have the functions in C programming, and followed by the functions, we shall discuss the escape sequences used in C programming, and later, we shall come into the important concept, which are the data structures. Followed by data structures, we shall discuss strings used in C programming, and after that, we shall discuss structures and unions, and finally, we shall come into memory allocations. Once after we are done with the memory allocations, we shall discuss some important sorting algorithms which are designed in C programming. Now, without wasting much time, let us quickly dive into the history of C programming. As we all know that, Dennis Ritchie is the founder of C programming language. Prior to C programming language, we had many other programming languages such as P, COBOL, ASGOL, and many more, which were usually the machine-level programming languages, and it was very difficult to develop Linux operating system using those machine-level programming languages. This was the reason which Dennis Ritchie founded C programming language in the year 1972 at Bell Laboratories, USA. C was originally implemented on the first machine, which is DEC PDP-11. C is well known to be flexible and versatile, which allows maximum control with minimal number of commands. And it is a very user-friendly programming language, and it is highly readable. Now we shall get into the next stage, where we'll discuss the features of C programming language. The first feature of C programming language is, it is a high-level programming language. Any programming language is considered as a high-level language if it is written in English or user-readable language. Now, we write programs in C language using English or user-readable language, which is user-friendly and easy to understand. Followed by the first feature, the next one is structured language. C language is considered to be a structured programming language as it improves the clarity and quality, and it reduces the development time for designing a programming software. Followed by this, the next feature is rich library. C language has its own library which includes most of the arithmetic and logical operations which are predefined. We just have to include the libraries which we need, and we can execute the functionality of those libraries without having to code them separately. Followed by that, the next feature is its extensibility. The programs which are written in C language are highly extensible. Followed by this, we have the next feature, which is recursion. Recursion is a feature offered by C programming language where we don't have to write the function for multiple times. Instead, wherever we need the function, we just have to call it. This feature reduces the time involved in the development cycle and also improves the code functionality. Followed by this, the next important feature offered by C programming language are the pointers. Using the pointers, we can directly interact with the physical memory of the computer system. The next one is faster execution. Using C programming language, the users can execute programs faster than its predecessors. And the final feature is memory management. The C programming language offers many functions where we can dynamically and directly interact the memory of the computer system. Many functions such as malloc, calloc, realloc, and free are the dynamic memory allocating functions used in C programming language. Followed by this, the next stage is the installation of C in Windows system. Since I'm using Windows system, we can learn the installation of C in Windows. Now, C can be installed in computer system in multiple ways. The most basic way of installing C is installing Turbo C in your system. If you are a fan of Eclipse IDE, then you can directly download GCC compiler and add C nature to the Eclipse IDE and continue to execute your programs. Compared to the previous two methods, the last method is completely simpler and easy to use. You can directly use an online compiler where you can directly write your code and execute it. Now, let us try to install Turbo C first. To install Turbo C in your system, you just have to download Turbo C++ for 7, 8, 8.1 and 10. You can either choose a 32-bit version or a 64-bit version. Since my system is a 64-bit version, I have chosen 64-bit version and it is lying in my downloads section. So this is my Turbo C++ executable file. All I need to do is just install it. Select yes. Here you go. You can see the installation wizard here. Just select next and accept the agreements of Turbo C++. Next, next, and you're done. Installation will be completed within a moment and here you go. You have the finish button and Turbo C is installed in your system. And this is the editor you'll find for Turbo C and here you can write your programs and execute. So this is how the Turbo C++ editor looks like. Now the next method which I was talking about is Eclipse. To use C programming in Eclipse IDE, you need to download an Eclipse version for C and C++ developers. Now, you can see the link for Eclipse IDE installer for C and C++ developers. All you need to do is download this installer and run it, and after running it, you'll find options for various IDEs of Eclipse. All you need to do is just select C or C++ developers version, and you'll have the Eclipse. As you can see, I have already downloaded the Eclipse installer. All I need to do is to run this installer now and I'll be getting a dialog box where I have to choose Eclipse IDE for C, C++ developers. Once after you install the Eclipse IDE, the next step you want to do is to install the GCC compiler. To install the GCC compiler, you need to visit an official website which is MINGW. Here you can either choose the 32-bit version or you can choose a 64-bit version and install it in your PC. This is the download link. I have already installed MINGW 64-bit in my system, and once after the installation is finished, you can directly start your Eclipse. Once after the Eclipse IDE is installed, your IDE looks something like this. Once after you start the Eclipse IDE, the first thing you need to do is to set the C++ and C nature. You can select the C++ or C IDE nature by selecting this icon which is on the right topmost corner of Eclipse IDE. After selecting that, you can see a pop-up where the first option is C or C++. This perspective has been selected here and just select open. And that's how you start working with Eclipse IDE. And now comes the easiest way to use C programming language in your computer is by choosing an online compiler. This is the official site for using an online compiler where you can write your programs directly onto the text editor. Now with this, we shall move on to our next stage where we shall discuss C tokens. The C tokens available in C programming language are keywords, constants, special symbols, strings, identifiers, and operators. Now we shall discuss about each one of them in detail. Firstly, keywords. Keywords are defined as those variables which have special meaning and are predefined in C libraries. So this was a definition for keywords. Keywords are something which are predefined in C libraries which you cannot rename or you cannot reprogram. For example, if we're using the loops like do-while loop, for loop, then the methods and the functionality of those particular keywords is predefined. You cannot access them or you cannot redefine them or reprogram them. So this is the meaning of keywords. Some of the basic examples for keywords are for, if, else, main, void, etc. Now, let's move on to the next stage of keywords where we'll have the complete description of all the keywords available in C programming language. So these are the complete description of all the keywords which are used in C programming language, which you cannot either access or you cannot change the functionality or you cannot reprogram them. These are all predefined and loaded into C libraries. Followed by this, we shall discuss constants. The definition of constants goes like this. Constants or literals are like variables. But the difference is that the values of constants are fixed. Once declared, they cannot be changed. Now let's understand this in detail. Variables are those, once after you declare them, you can either change their values or you can also perform operations on them. But if you declare the same variables with the keyword const in front of them, then you cannot change them. You cannot change the value which is stored in the variable declared with const keyword. The syntax for declaring constant type variables are const followed by data type and after that the variable name, or you can also declare a pointer type variable name with using const keyword. Followed by this, the next one is the types of constants available in C programming. The first one is the integer constants. Followed by that we have floating point constants. Later we have character constants. Then we have string constants and finally octal or hexadecimal constants. Next are strings. The definition of strings is defined as follows. Strings are defined as a collection of characters defined in form of an array and at the end with a null character which describes the end of the string to the compiler. Strings are nothing but character type arrays. In strings, we have the alphabetical data which is stored in the form of arrays. Alphabetical in the manner A to Z, not the numbers or special symbols. Once after the string is declared in C language, it has to end with a null character which is the only special character used in strings which will indicate the compiler that it is the end of that particular string. Now, we shall learn the syntax for declaring a string in C language. The syntax is, first you need to begin with the data type which is char, followed by that we have to specify the string name and at the end you have to specify the length you are using for your string. This will be fixed. This will not be varied in the runtime. Followed by strings we have special symbols. Special characters are the symbols or single characters or sequence of characters that have a special built-in meaning in the language and typically cannot be used in identifiers. Let's understand this in a bit detail. Special symbols are characters such as dollar, ampersand, brackets, etc. are having a special meaning which is predefined in C libraries while designing the C programming language. This is the reason for which they are used in a particular segment of code. For example, if you consider ampersand, the ampersand symbol is used in printf and scanf statements only. This ampersand symbol is dedicated to locate the address of the variable which you have declared in your program. And when you come into modular symbol, this is especially used along with the data types for specifying the data type. For example, if you are declaring an integer type data type, you'll be using modular symbol along with D. If you are declaring string type data type, then you'll be using the modular symbol along with S. So this is about the special symbols, and the basic examples for special symbols used in C programming language are modulus, ampersand, and brackets. The next thing is identifiers. Identifiers are defined as the names that we declare in the program in order to name a value, variable, function, array, and etc. Let us understand identifiers in a little bit detail. Identifiers are nothing but the name you declared for your variables and values, functions, arrays, etc. which you are using in your program. It's like naming a person. For example, if you want to talk to a person, then you call him by his name. So in the same way, if you want to access a particular memory location or value or an array or whatever the function you're using in your program, you call it with a name, which is its identifier. For understanding this, let us consider a simple example, which is int x is equals to 10. Here, int is the data type which you're specifying for your identifier and x is the variable name which will be storing the value 10. Followed by this, we shall also understand some basic rules for declaring identifiers. Some of the basic and important rules used for declaring identifiers are: first character should always be an alphabet or an underscore. The succeeding characters can either be digits or letters. For example, special characters are not allowed except underscore. And the last rule is that identifiers should not be keywords. Let us see the examples to understand these rules. The first type of examples are valid identifiers which are declared using the rules declared for identifiers in C programming. For example, integer a, which does not have any kind of special symbols or numbers in front of it. And the next one is underscore a b, which is valid because underscore is the only special symbol which is used here. Followed by that, we have alphabet in the starting place, and after alphabets, we have numbers. So this is also valid. And the invalid type of identifiers are: you cannot specify the number at the starting position of an identifier. Followed by that, You can also not include space in between the name of an identifier. If you want to include space or if you want to specify space, then you can use underscore. Followed by that, you cannot specify the keyword as your identifier. Here, long is a keyword which happens to be a data type. Once after you have understood the rules for declaring identifiers in a C program, let us move on to the next concept, which is operators. We have the following operators in C program. We shall understand about each one of them in detail. The first one happens to be arithmetic operators. Followed by that, we have increment or decrement operators. And next, we have assignment operators. Followed by that, we have relational operators. Next, logical operators. And last but not the least, the bitwise operators. Let us understand each one of them in detail. Firstly, arithmetic operators. The arithmetic operators are used to perform mathematical calculations such as addition, subtraction, multiplication, division, and modulus. Let us go through a simple program to understand the functionality of arithmetic operators. This particular program features all the arithmetic type operators that we use in C program. Now let us try to compile this program and see how does it work. As you can see, the code has been successfully compiled and we have the output. Firstly, we have declared three variables here using the integer data type. The first variable is A, which stores the value 9 in it. Followed by that, we have the next variable B, which stores the value 4 in it. And the third variable is an integer type variable, which is empty. Now we'll use the third variable to store the results of the operations performed on A and B. Firstly, we are going to perform addition operation on the first two variables A and B, and the value will be stored inside C. Similarly, the next operation would be subtraction, and the subtraction result will be stored in the value C. Followed by that, we have multiplication, division, and modulus. As you can see, the program has been successfully compiled and the results are shown as below. Firstly, the addition 13, the subtraction 5, multiplication 36, and division is 2. Finally, the modulus operation, which resulted in a remainder, which is 1. Now with this, I hope you have understood the basic functionality of arithmetic operators used in C program. Now, let us discuss the next type of operators, which are increment operators and decrement operators. Increment operators and decrement operators are basically used when loops are included in program. We shall discuss about loops in a much detailed way in the upcoming concepts. For now, let us understand that the control statement will be executed for multiple times when increment or decrement operators are included in the program. I++ defines that it is incrementing and I-, defines that it is decrementing. You can either use any of the variables from A to Z along with the increment symbol, which happens to be the plus plus, and decrement symbol, which happens to be minus minus. With this, let us discuss about the next type of operators, which are the assignment operators. Assignment operators are used to assign values to the variables in C programming language. For example, if you are declaring certain value to a variable in C program, then you must use assignment operator. For example, we have int a is equals to 10. Here, int is the data type and a is the variable name. So, to assign the value 10 or to save the value 10 in the variable a, you need to use the assignment operator, which is equals to. And on the same way, if you're using double equals to symbol, it means that you're comparing the values stored on LHS and RHS. For example, if you're using a double equals to b, then the compiler understands that if the value of a is equals to b, then it has to execute certain commands in the upcoming statements. Let's discuss about that in the upcoming concepts. For now, let us move on to the next type of operators, which are relational operators. Relational operator is a programming language construct or operator that tests or defines the relation between two entities or two variables. Examples for relational operators are as follows: greater than, less than, equals to, and not equals to. Let us understand relational operators in a much better way. Relational operators are generally used between two or more variables. If you had to compare the greatest among the two values, for example, consider a is equals to 10 and b is equals to 20. Now, the user wants to know which is the greatest variable. Then, you will apply an if condition and declare two variables inside it, as shown here. If A is equals to or less than B, then a particular statement or particular code segment will be executed. This condition will be true only if A is less than or equals to B. Followed by the relational operators, we shall discuss about logical operators. The logical operators used in C programming are logical AND, logical OR, and logical NOT. The logical operators are used to perform certain operations on the given expressions. First, we shall discuss logic AND. To execute logic AND, both the sides of the LHS and RHS must be true. Only then it will result in a true value. If any one of the other value is false, then it will result in a false value. Similarly, when we come into logical OR, the logical OR functions with either one of the values of the two comparisons should be true. For example, if you're comparing A or B, then either A should be true or B should be true. Then the resultant will be automatically true. If both the values are false, then the resultant will be false. Similarly, when you come into logical NOT, the major functionality of logical NOT is to convert the true value into false. If you're using the NOT operator in front of a true value, then the value will be converted into false. Followed by the logical operators, we have the bitwise operators. The operators are used to perform bit operations. Decimal values are converted into binary values, which are the sequence of bits, and bitwise operators work on these bits. We have 6 types of bitwise operators. Firstly, bitwise AND, bitwise OR, bitwise NOT, XOR, left shift, and right shift. Followed by this, we shall enter into the most important concept, which is data types and variables used in C language. The data types used in C language are categorized into 4 varieties. Firstly, the basic data types. Next, we have the derived data types. Followed by that, we have enumeration data types. And lastly, we have void data types. We shall discuss about each one of them in detail. Firstly, the basic data types. The basic data types described in C language are int, char, float, and double. And followed by that, the derived data types are the array, pointer, structure, and union. The enumeration data type is none other than the data type which is declared using the keyword enum in front of it. And lastly, we have the data type void. Now we shall discuss the variables used in C programming. Variable is defined as a reserved memory space which stores the value of a definite data type. The value of variable is not constant. Instead, it allows changes. To understand variables in detail, variables are something similar to identifiers. Variables actually store the value which you assign to them. For example, if you declare a variable A with certain data type, say float, and you assign some value into it, say 100, then it will store that particular 100 value in a memory location with float data type. That is, the value of 100 will be stored as 100.00 in a certain memory location in the memory allocated to it. Now let us understand the types of variables available in C programming language. There are mainly 5 types of variables supported in C programming language. They are local variable, global variable, static variable, automatic variable, and external variable. Now let's discuss about local variables first. Any variable that is declared inside a code block or a function that has scope confined to that particular block of code or function is called as a local variable. Let us understand this in a detailed way. For example, you are defining a function inside a main program. So, inside the function, you will be declaring some kind of variables like int a or int b. So, that particular variable is eligible to be used inside only that particular function, but not inside the entire code. So, this is why it is called as a local variable, as its scope is been confined to one particular main program or one particular function, not to the entire program. For example, here I have declared a function by name edureka, and inside I have declared a local variable by the name local variable, and I have stored certain value that is 10 into it. So, I will be able to access this local variable only inside the function edureka, but not outside the function edureka. Now, let us discuss about global variables. You can see that the global variable is directly the opposite of local variable. The global variables are actually declared outside the main function itself. Before even you start coding, you'll be declaring first the global variables. The speciality of global variables is that You can access the global variables in the main program as well as the function, or in other way, I can say that the global variables can be accessed anywhere in the program. Followed by the global variables, we have the static variables. The static variables are also called as variables, but the only difference is that static variables will never allow you to change the value which they have stored. For example, you can run this code. Here, I have declared a local variable 10, and followed by that I have also declared another static variable with the name static variable, and I have assigned the value 10 into it. Now I can perform some operations such as adding one value to the value stored in local variable. The local variable will accept it and execute the code, and the value of the local variable will turn into 11. But when you come into static variable, and if you want to try this operation on that particular variable, then the compiler will throw an error saying that the value of the static variable cannot be changed. Followed by this, we have the automatic variable. The automatic variables can be declared by using the keyword auto. By default, all the variables which you use in C programming language are automatic variables. For example, you can see this. I have a main function inside which I have declared two different variables. One of them is the integer data type with local variable name which stores the value 10 into it. And the other one is also an integer type variable auto which stores the value 20. I can either use this auto keyword, or I can just simply declare a variable with integer data type and I can type the variable name and declare the value into it. Both are considered to be automatic variables. Followed by this, we have external variable. External variables are declared by using the keyword extern, similar to the other one which is auto variable. Here we'll declare the external variables with the keyword extern. We can share a variable in multiple C source files by using an external variable. For example, I have declared an external variable here of integer data type, and the name of the external variable is external, and it is storing the value 10 inside it. Don't forget to see the keyword which I have used, which is extern, to declare the external type of variable. Now, similar to the rules of declaring identifiers, we have also the same rules for declaring variables. The rules are, a variable can have alphabets, digits and underscore, but not special symbols. Followed by that, we have a variable name can start with alphabet and underscore only. It cannot start with a digit. The next rule is that there should not be white space in between the variable name. As we discussed in the case of identifiers, no variable name or no identifier name should include a space in between them. If you want to specify space, then you must use underscore, but not the actual space. Followed by that, the last rule is that a variable name must not be any reserved word or keyword. Example, integer or float. We shall see some examples for valid type of variables that we can declare in C language. Firstly, int a, where the variable name did not start with any of the special characters or space. It just simply started with an alphabet. Followed by that, we have another way of declaring variables with underscore, which is the only symbol or the special symbol which is eligible to be present in a variable name. Followed by that, we have the last type of valid variables name, which started with an alphabet and it ended with a digit, which is acceptable. Now we shall also discuss some invalid types of variable names, where the first one is int2. Here, the variable name started with an integer value or a number, which is invalid. Followed by that, we have another variable where we have included an actual space between the variable name. That is, we have included an actual space between the variable name a and b, which is invalid. And lastly, we have declared a variable name with a keyword which is long. Long happens to be a data type and it is a keyword, so this is also not acceptable. Followed by this, we shall move into the preprocessor directives, which happens to be the most important concept in C programming language. The preprocessor directives are lines included in a program that begin with a character #, which make them different from the typical source code type. They are invoked by the compiler to process some programs before compilation. It is a macro processor that is used automatically by the C compiler to transform your program before actual compilation. Let us understand preprocessor directives in a much better way. Preprocessor directives are anything which you have written in a C program followed by an # keyword. For example, stdio.h is a preprocessor directive, which means standard input output. This particular preprocessor directives activates the input and output units to perform a C program operation. The code for this preprocessor directives is previously written by the C developers and it is stored in the C library. Now let us understand how the preprocessor directives work. Firstly, the preprocessor directives are declared in a high-level language which is user's language. For example, #include stdio.h. Before compiling the actual program, the compiler will compile the preprocessor directives. The preprocessor directives will be in a pure high-level language which will be in a relocatable code. So this relocatable code will be converted by the compiler into assembly-level code and will be passed to the assembler. Now, the job of the assembler is to understand the codes which are sent to it and to perform the operation which is expected from it. That is, to load the particular library. Now, to load the particular library, the command will be sent to the loader and linker in a pure machine level language, and the library which the user is expecting will be loaded to the C program. And that's how the C program will be executed with the libraries which he needs and with the input and output units which he requires. Now let us discuss some of the preprocessor directives. First one is #include. The #include preprocessor directive is used to paste code of given file into the current file. It is used to include system-defined and user-defined header files. There are two variants to use #include directive. The first way is to write #include and the file name between the greater than or lesser than symbols. And the next way is to write #include and include the file name between the double quotes. Followed by that, we have #define. The #define preprocessor directive is used to define constant or micro substitution. It can use any basic data type. The syntax for declaring #define is as follows: #define and the token value. The next type of preprocessor directive is undef. The #undef preprocessor directive is used to undefine the constant or micro defined by the #define. In a simple way, you can undo anything which you have done using the preprocessor directive #define. The syntax for undef is #undef and the token which you have defined using #define. The next preprocessor directive is ifdef. The ifdef preprocessor directive checks if the macro is defined by using the keyword #define. If yes, it executes the code. Otherwise, #else code is executed if the else code is present. The syntax is ifdef macro, a code segment, and if it is not present, then endif, or an else tag will be executed if the code segment inside the else tag is present. The next preprocessor directive is ifendef. The ifendef preprocessor directive checks if the particular macro is not defined by #define. If yes, it executes the current code. Else, the else code will be executed if it is present in the macro. The syntax for ifendef is #ifendef macro and the code present inside the macro. If the condition gets failed, then the code inside endf will be executed. Followed by that, we have #if. The #if preprocessor directive evaluates the expression or condition if the condition is true. It executes the code, otherwise, else if or else or endif code will be executed. The syntax for #if is #if expression for comparing, and if the comparison is true, then the code inside it will be executed, else the endif code or the else if or else code will be executed. The next one is #else preprocessor directive. The #else preprocessor directive evaluates the expression or condition if the first if condition goes false. If the first if condition goes false, then the control will directly enter into else part and the code which is declared inside the else part will be executed. Followed by this, we have #error. The #error preprocessor directive indicates any error which is present inside the preprocessor directive. The compiler gives fatal error message if the #error directive is found and skips further compilation process. The next one is #pragma. The #pragma preprocessor directive is used to provide additional information to the compiler. The #pragma directive is used by the compiler to offer machine or operating system feature. The syntax for #pragma is #pragma followed by the token. With this, let us execute our first C program. As you can see, this particular example is our first program that we are going to execute in C language. Now let us try to run it. As you can see, the code has been getting compiled and the hello world message is printed successfully. With this, let us dive into the control statements that are used in C programming language. Control statements enable us to specify the flow of program control. They specify the order in which the instructions in a program must be executed. They make it possible to make decisions or to perform tasks repeatedly or jump from one code segment to another. Let us understand this in a bit detail. Control statements are actually user-defined conditions for the compiler. The user specifies a particular condition in front of a code segment and asks the compiler to execute that particular code segment if and only if the condition which he specified to the compiler is true or not. If the condition is true, then the code will be executed. If the condition is false, then the code will be skipped and the next code segment will be executed. Sometimes this also enables us to make decisions, and in the other case, we can also perform some particular task for a repeated number of times, such as loops. Now, you can also jump from one code segment to another directly if the condition happens to be false. This can be used in case of switch. Let us execute all the conditional statements present in C program and understand each one of them in a much detailed way. Firstly, we shall understand if condition statement or if control statement. The if statement in C is defined as a programming conditional statement that, if proved true, then performs a particular operation and displays the information inside the statement block. For example, if you have a condition in front of a code segment that you want to execute, but you have a condition to execute it. In that particular case, the code segment which you wanted to execute will be executed only if your condition what you specified will be true. Else, that particular code segment will be eliminated or the control will not enter into that block of statements. To understand this, we shall go through a flowchart. Here, this particular flowchart will define the working of if control statement. Firstly, the control will enter start and a particular code segment in the starting point of the program will be executed. Followed by that, the control will directly encounter the if condition. This is the place where you will provide your condition. If that particular condition happens to be true, then the control will pass through the condition and will execute the statements which are provided inside the condition. If the condition is false, then the control will directly jump to the next set of statements which are after the if condition statements. Let us try to execute a program to understand this in a much better way. This particular example is based on if condition. Here, I am specifying a variable by the name number which is integer data type. Here, I will be asked by the compiler to enter any particular number which is an integer. So, the number should not be float or any other. So, it should be just an integer. Then, the compiler will scan the input whatever I provide to the computer. Then, it will run a particular condition specified in the if block, which says if the number provided by the user will result in a reminder is equals to 0, then the code segment which is present inside the if condition block, that is a printf statement, should be executed. Else, it should directly run out of the if block and execute the next particular statement which is return 0. Now, let us try to execute this program and see how does it work. As you can see, the code has been compiled here. Now the program is asking me for an input. Now let me try to give an even number, which is 10. As you can see, the modulus of 10 against 2 will result in a reminder 0. So, the condition which I specified here is true and the code segment inside it is been printing here. Now, let us try to provide an odd number and see how does it work. As you can see, the code has been compiled now. Now, let me specify 7, which happens to be an odd number. Let us see if this works or not. As you can see, the program directly finished and the code block which is present inside the if block did not get executed. Now followed by this, let us understand if-else condition statements. The if-else control statement or conditional statement is similar to if condition, but the only difference is that you will also have an else block here. Let us define it. If-else statement in C language is defined as a programming conditional statement that has two statement blocks over a condition. If proved true, then the block inside the if will be executed. And if false, then the else block will be executed. To understand this in a much better way, let us go through a flowchart. In this particular flowchart, the control is started from executing the start statements Once after the starting statements are executed, it will encounter a condition. In this particular condition, if the condition is executed and the result is true, then the control flow will enter inside the if block statements. And the if block statements will be executed. And then it will pass into the last set of statements. In case, if the condition provided inside the condition block happens to be false, then the condition will be directly entering into the else block of statements, which will be a separate block of statements from the if statements. Then the else block of statements will be executed and the control comes out of the else block of statement into the next set of statements. Now, let us see practically and understand how does it work. So this particular example is related to else if statements. Firstly, the compiler will compile the code and the computer will ask me to enter a particular number. So here if the particular number happens to be an even number, then the first set of statements which are present in the if block will be executed. If the condition fails, then the control will directly jump into the else block of statements and will execute the statements present inside the else block, which will say that the number you have inputted is not an even number, instead it is an odd number. Now let us try to execute this statement and see how does it work. Now you can see that the program has been successfully compiled and the computer is asking me for an input. So first let me provide an even number, which is 4. As you can see, the modulus of 4 is resulted in 0 and the if block statements have been successfully executed and it says the number you have inputted is an even number. Now let us try to run this code again and let us provide an odd number this time and let us see if else block is properly working or not. Now let us provide an odd number, which is 9. As you can see, the compiler have understood that the number is 9 and else block of statements have been successfully executed. Let us try to understand the next type of control statements, which is the else if ladder. Else if ladder in C programming language is defined as a programming conditional statement that has multiple else if statement blocks. If any of the condition is true, then the control will exit the else if ladder and execute the next set of statements. As you can see, this is completely similar to the else if control statements. But the only difference is that you have multiple else blocks here. For example, if the first if condition fails, then the control should enter the next else statements. What if the next else statement is also false? Then the control will enter into the next else block. Here you have multiple else blocks. So once the compiler finds the proper and true else block, then that particular else block will be executed. Let us understand this in a much better way using a flowchart. As you can see, the control will start from executing the initial steps, and after that it will encounter the first condition. If the first condition is true, then the statements inside the first condition will be executed. If the first condition is false, then the control will directly enter into the second condition. If the second condition happens to be true, then the set of statements inside the second condition will be executed. Else, the condition will jump into the third condition or the next following condition. And if the condition is true, then the statements inside that particular condition will be executed. If the last condition is also false, then the control will directly exit the else if ladder and execute the next set of statements. Let us understand else if ladder in a much better way by executing a practical example. As you can see, this particular example is based on else if ladder. Here, I'll be asked by the computer for inputting a number. So, if I input the number and if the particular number which I have inputted by chance equals to 10, then the first set of if block statements will be executed. If the number is not 10, instead if it is equals to 50, then the next else if block will be executed. If the number is not equals to 10 and not equals to 50, then if it is equals to 100, then the third set of statements will be executed. If the number which I have inputted will match none of the above statements, then a final else block will be executed, which will say that your number is not equals to 10 or 50 or 100. Now let us try to execute this program and see how does it work. As you can see, the program has been compiled here and the computer is asking me for an input. So to execute the first set of statements, my number should be 10. To execute the second set of statements, my number should be equals to 50. Or if I choose to execute the last set of statements, then the number which I input should be equals to 100. If I don't want to execute all the above three statements, then I can input any of the random number to execute the last set of statements. Now let me try to input the number 100. As you can see, 100 matched with the third set of statements and the message which is present in the third block is executed. With this, let us move on to the next type of control statements, which is nested if. Nested if statement in C language is defined as a programming conditional statement that comprises of another if statement inside the previous if statement. In a simple way, it's actually an if statement which includes an if statement inside it. To understand this in a much better way, let us consider a flowchart. As you can see, this particular flowchart describes the functionality of nested if. Here, the starting set of statements will be executed and the first condition will be encountered. If the condition happens to be false, then a particular set of statements will be executed and the loop terminates. In case, if the condition provided in the if block happens to be true, then the control will enter inside the if block and it will encounter another condition inside the if block, which happens to be another if statement. So inside another if statement, you have a condition. If true, then a particular set of statements will be executed. If false, another set of statements will be executed. And finally, the control will exit the if condition. Let us execute a practical program to understand this in a much better way. As you can see, this particular example is based on nested if condition. Here, we have two variables of integer data type, which are v1 and v2. Followed by that, we have an if condition. If the entered v1 value is not equals to v2, then it should enter the first block of if statements. If they are equal, then the control will enter into the else block of statements. Now, let us try to execute this program and see how does it work. As you can see, the program has been successfully compiled and the computer is asking me for an input. So let me input two same values. Second value is also same as the first value. And inside the first if condition, we have another if condition which compares both the numbers. If v1 is less than v2, then the first block of statements will be executed, which is this. If it is false, then this particular statement will be executed. Now with this, let us move on to the next type of control statements, which are switch control statements. The switch case in C language is defined as a programming selection statement that checks for a possible match to the provided condition against the available cases. If none of the case matches, then the control will execute the default statement block. This is completely similar to the else if ladder. Here, you'll be having multiple cases. So, the control or the compiler will check for the match between all the available cases. And then, if any case matches, then the code segment inside that particular case will be executed. If the input does not match any of the provided cases, then there will be a default case or default code segment which will be executed by default. Now, let us try to execute a practical example to understand switch control statement in a much better way. But before that, let us check out the flow diagram for switch control statement. In this particular flowchart, you can see that the control entered the switch condition statement, and inside the switch condition statement, it will be received a value which will be compared against the cases provided in the program. As you can see, the value is being compared with the first conditional case here. If the condition matches the value, then this particular statements will be executed which are located inside the first case. Else, the control will enter into the next followed case, and inside that case, if the value is matched, then the statements of that particular case will be executed. Similarly, if that case doesn't match, then the final case will be compared. If it finds a match, then the statements 3 will be executed. If the value does not match any of the provided cases, then the default statement will be executed, which will be provided at the end of the switch control statements. Now, let us try to execute a program to understand switch control statement in a much better way. As you can see, this particular example is based on switch control statement. In this particular program, the compiler will ask me to enter any of the arithmetic operators. For example, I have selected plus, minus, into, and divided by. So once after I enter the operator, the program will ask me to select any two operands. That means I need to provide two different numbers. So once after it gets the operands and operator, it will perform the operation which I requested to it. So first, if I had provided plus operation, then this particular code segment, which happens to be the case plus, will be executed. If I provide the minus operation, then this particular segment of code which works with minus will be executed. Similarly, into and divided by. So if I provide the operation which does not match any of the above cases, then a default case will be executed. Now let us execute this program and see how does it work. As you can see, the program has been successfully executed and the compiler is asking me for an input. Now let me provide minus operator. The program will ask me for two different operands. Let me provide the first operand as 12 and the next operand as 5. Now, the case second, which happens to be the minus, is been selected and the code segment inside that will be executed. So according to the result, we have 12 minus 5 is equals to 7. So that's how the switch control statement works. Now, let us try to understand the next type of control statement, which is the ternary control statement. Ternary operator in C language is defined as a programming conditional statement that is similar to an if statement, but shorter in code length. The control checks for a condition and executes either of the two statements. So, according to the definition, it is actually an if statement, but shorter in code length. In if condition, you actually provide an if condition along with a condition specified inside the if brackets. If the condition happens to be true, then you will have to write another code for the particular statements you want to execute. That's the reason the code length for if block is increased in size. But if you want to code the same thing using a ternary operator, your code length will be decreased to one line, where you will provide the condition along with the possible outcomes. If the condition is true, then the first outcome will be executed, else the second outcome will be executed. To understand ternary control statement in a much better way, let us go through this flowchart. As you can see, the control statement will first encounter the condition. If the condition is true, then a particular code segment will be executed, else the other code segment will be executed. To understand this, let us execute a program. As you can see, this particular example is based on ternary operator. So this particular line is the ternary operator. Here, we have max is equals to A is greater than B. If it is true, then A should be greater, else B should be greater. So now let's execute this program and see the result. As you can see, the program has been compiled successfully and it is asking me for two different numbers, one for A and one for B. Now let me enter a smaller value for A, that is 9, and a bigger value for B, which is 10. As you can see, 10 is the largest number and A is not greater than B, so B is being displayed as the greatest number amongst the two. With this, let us move on to the next control statement, which is break control statement. The break control statement in C language is defined as a programming conditional statement that is designed to exit the control from current code segment to the next code segment when a specified condition is satisfied. We have checked the break condition statement in switch control statement. Each and every case in switch control statement will include a break which specifies that if the case is matched, then the control flow should exit the switch case and execute the next particular statements. With this, let us also check the flowchart for break control statement. You can see that the control has entered the condition. If the condition is true, then the control will be break. Else, the condition is repeated and executed. With this, let us move on to our next topic, which is loops. Loop control statements in C are used to perform looping operations until a given condition is true. Control comes out of the loop statements once condition becomes false. There are three different types of loops in C language, which are do-while loop, and for loop. And let us understand loops in a much better way. Loops are actually similar to conditional statements. In C programming language, if you had to execute a particular code segment for a repeated number of times, say 5 times, then you can actually specify that to the compiler. You can just write a for loop or a while loop or a do-while loop along with a condition stating that you have to execute this particular code segment for 5 times. Then the compiler will automatically understand it and will execute the same code segment for 5 times. Let us understand each one of these loops in a much better way along with flowcharts and examples. Firstly, we shall deal with for loop. For loop can be defined as a precise loop which has initialization, condition, and increment or decrement operators. So firstly, initialization. Initialization process is where you declare an initialization variable and you will assign it to a particular number. Usually, the initialization value is 0. Followed by that, we have a condition. This is where you specify to the compiler for a particular number of times or iterations. According to the previous example, if you wanted to execute a particular code segment for 5 times, then you have to specify if initialization variable is less than or equal to 5, then execute this particular segment for the next time. Once after that particular code segment is executed, the very next step it takes is increment or decrement. This is where the compiler will check if I have reached the limit or not. If the limit is reached, then the control will exit the loop. If not, then it will execute the loop. Now, let us see a flowchart to understand this in a much better way. As you can see, the control begins at initialization and later the condition is checked. If the condition is true, the statement will be executed. And after that, the increment or decrement process takes place. Once after the increment or decrement process is done, the control will again check the condition. If the condition is true, then the control will enter the loop again. If the condition is false, then it will exit the loop. Now, let us execute a program to understand this in a much better way. As you can see, this particular example is based on for loop. Here, I am trying to print 5 different values, which is 1 to 5. So this particular loop will be executed 5 times. So this particular value is the initialization value, and this particular code segment is the condition where I have specified if the initialization value is less than or equal to 5, then the code must be executed. And finally, I have the increment operator, which increments once the first loop execution takes place. Once after the first loop execution finishes, the incrementation value will be increased from 1 to 2, and the condition is again checked, and according to the condition, if it is true, the loop will be executed. If false, the condition will be exited. Once after the limit will be crossed to 5, then the loop will exit. Else, it will continue executing the statements present inside that loop. Now let us try to execute this loop and see how does it work. As you can see, the code has been successfully compiled and the result is been provided here. As you can see, the control flow has encountered the for loop first, and the initialization value was 1 and the condition was true, and the statement has been executed. Once after this loop finishes the first iteration, the initialization value will be incremented to 1 as the increment operator here is been executed now. Once after it changes to 2, the condition is again checked and the condition is true, the loop will be executed. Similarly, it will execute for 3 and 4. And finally, once after the increment value reaches to value 5, the condition is checked again and the condition is true. So the 5 number will be displayed here, and once after the increment goes to 6, then the condition fails. Then the control will exit the loop and the next set of statement will be executed. So that's how the for loop works. Now let us move on to the next type of for loop, which is advanced for loop or nested for loop. As you can see, this is also basically a for loop. But the only difference is that this includes a for loop inside the external for loop. To understand this, let us go through this flow diagram. As you can see, the control flow starts to execute the beginning statements and finally it encounters the first for loop condition. If the condition is true, then it will enter the inner for loop. Once after the control enters the inner for loop, the inner for loop will be executed until the condition of the inner for loop is true. Once the condition inside the inner for loop fails, then the control will be passed to the increment or decrement variable of the external for loop. Here is where the counter variable will be updated and the condition of the outer for loop is again checked. If it is true, then the inner for loop will be executed again. The inner for loop will be executed until the inner condition is true. Once after the inner condition fails, again it reaches the outer increment decrement operators. So the counter variables will be updated. This cycle will be executed until the condition of the external for loop is true. Once after the external for loop fails, then the statements outside the external for loop will be executed, or the control will exit both the for loops. Now let us try to execute a program to understand this in a much better way. So this particular example is based on nested for loop. So you can see that there is an external for loop here. So in this particular for loop you have a condition, and until this condition is true, the internal for loop will be executed. Now let us try to execute this program and see how does it work. As you can see, the program has been successfully compiled and the data has been displayed here. As long as the first for loop is true, the internal for loop is executed and the data is printed. Now let us try to understand the next type of loop, which is the while loop. The while loop can be defined as a loop which executes itself repeatedly until a given Boolean expression or a condition is true. Now let us understand while loop through a flowchart. As you can see, similar to the previous loop, even the while loop has a decision box. Inside this, the condition will be provided. Once after the control encounters the condition, and if it finds the condition to be true, then the statements inside the while loop will be executed. Else, it will exit the while loop. To understand this, let us execute a program. As you can see, this particular example is based on while loop. We have the counter variable which is declared to the value 1, and followed by that we have a while condition loop here. And inside the while loop we have a condition which states that the counter variable should be less than or equal to 5. Until this condition is true, the loop will be executed. And you can find the increment or decrement variable which is present inside the while loop. So inside the while loop you can see that count plus plus, which means increment operator. Now let us try to execute this program and see the output. As you can see, the program has been successfully executed and the while loop ran until the condition was true, which states that the counter variable should be less than or equals to 5. So when the counter variable reached the maximum limit, the while loop got terminated and the next set of statements were executed. Let us understand the next type of loop, which is do-while loop. Do-while loop is completely similar to the while loop. The only difference is the condition will be stated at the end of the loop. You can see this when we execute a practical program. But before that, let us check the flow diagram of do-while loop. In do-while loop, the statements will be executed first. Once the statements are executed, then the condition is checked. If the condition is true, then the same set of statements are executed again. Else, it will exit the loop. Now, let us try to execute a program to understand how does it work. As you can see, this particular example is based on do-while loop. You can see that the counter variable j is initialized to 0, and once after the initialization process is done, you can see that we have directly entered into the do-while loop. And in this do-while loop, we cannot find any condition. Instead, the control is directly entering into the loop and the first set of statements are executed. Once the statements are executed, you can see the increment operator over here, which will increment the value of j from 0 to 1. And once after the increment is done, then the condition is checked. The condition states that the initialization variable should be less than or equals to 5. Until then, this particular code segment can be executed. The only difference between while loop and do-while loop is that the while loop will execute once after the condition is checked. But do-while loop is executed without checking the condition, which means the do-while loop will be executed at least for once. Now let us try to execute this program and see how does it work. As you can see, the program has been successfully executed and the output is also generated. The output was generated until the condition was true. With this, let us move on to the next topic, which is infinite loop. Infinite loop is a situation where the condition of the loop fails and the execution persists until you stop it manually. Infinite loop is not actually a particular type of loop. It is a situation where the condition whatever you have provided to other types of loops like while loop, do-while loop, for loop or nested loop, if the condition inside that loop is failed, then the compiler starts to execute the code segment present inside the loop for infinite number of times until you stop it manually. This is a risk which you might face when you fail to provide the proper condition to your loop. With this, let us move on to our next topic, which is based on pointers. The pointer in C language is a variable which stores the address of another variable. This variable can be type of int, char, array, function, or any other type pointer. The size of pointer depends on the architecture. The pointer in C language can be declared using asterisk symbol. So to understand pointer in a much better way, let me give you a small example. Let us assume that you have declared a variable by name n, which is of integer data type, and you have stored some value that is equals to 10. Now, what is happening here is n is pointing to a value which is 10 and it is storing the value in a particular memory location. So, n must have a memory location address. Similarly, as you have your house address, in the same way, every variable in C language also has an address. So, for example, n might be having some address like 1011. So, if you want to access n directly, then you have to access its address. So, for that, you have to declare a pointer which can access n directly through its address. So, to declare a pointer variable, you have to use an asterisk. which defines that the variable which you have declared is a pointer variable. So here I have declared a pointer variable p with asterisk symbol. That makes it as int star p is equals to address of n. So pointer variable p stores the address of n, which is directly accessing the value present in n. Before we execute a program, let us understand the advantages of pointers. We can return multiple values from a function using pointers. Followed by that, it makes you able to access any memory location in the computer's memory. We can dynamically allocate memory using malloc and calloc functions using pointer variables. Pointers in C language are widely used in arrays, functions, and structures. It reduces the code and improves the performance. Now, let us try to execute a simple program to understand pointers in a much better way. So this particular example is based on pointers. As you can see, I have declared an integer type of array with the name first array. And the first array size is 10. So inside the array, I have stored 10 different values starting from 1 to 10. And after that, I have initialized a pointer variable. So the pointer variable is pointing to the memory address of first array. So what I'm trying to do here is to print the address of each and every element present in the first array. Let us try to execute this program and see what are the addresses of all the elements present in first array. As you can see, the code has been successfully compiled and the addresses of all the values present in first array are being displayed here. For example, the address of value 1 is 0x7FFF056EA460. So this is a hexadecimal value. Once after you convert into a decimal value, then you can have a particular address where the particular value 1 is been stored. Similarly, all the other values have also got a different address through which they can be accessed. Now with this, let us move on to our next topic, which is escape sequence. Escape sequence can be defined as a combination of backward slash and a letter or digit. These sequences are non-printable and are used to communicate with display device or printer by sending non-graphical control statements to specify the actions like new line or tab space. Let us understand this in a much better way. Escape sequence is none other than a combination of backslash and a letter or digit. So we have a particular number of escape sequences in C programming which have different meanings. So basically, in a C program, we use new line and tab space to provide new line for the output or to provide a tab space between the obtained output if you are printing an array. So we shall understand what are the meanings of each and every escape sequence which is provided with C programming language. As you can see, these are the few examples of escape sequences designed in C programming language. The first one is alarm, which is provided by \a, and the second one is backspace, and the third one is form feed, and the fourth one, you know this, \n, which means new line, and after that we have carriage return, and followed by that, which is the common one we usually use while printing matrices, so that is tab space, and finally we have vertical tab. Followed by this, we have few more escape sequences, which are double backslash and backslash quote, backslash double quote, backslash question mark, and backslash triple n, which describes it as an octal number. And followed by that, we also have backslash xhh, which describes it as a hexadecimal number. And the last one is a null character, which we use in strings. So the next topic for our discussion will be functions. The most crucial and most important topic in C programming is functions. So what are functions? A function can be defined as a subdivided program of the main program enclosed within flower brackets. Functions can be called by the main program to implement its functionality. This procedure provides code reusability and modularity. Few examples for functions are library functions and user-defined functions. Actually, these are the only two types of functions which are available with C programming. Now let us understand functions in a much better way. For example, you have a program which has to add two numbers for multiple times in your program. For example, consider you had to design a program to add numbers. And inside your program, you had to add numbers for 10 times. So to design this program, you had to create an addition operation for 10 times. For the first set of two numbers, for the second set of two numbers, third set of two numbers, similarly for the 10th set of two numbers. So here you are accessing addition function for 10 different times. So this increases the code length and also increases the compilation time. So the compilation time doesn't matter for this simple operation, but if you're designing a bigger software, then this compilation time will matter a lot and the code length also matters a lot. Instead, you can just write a function where you can define the addition operation and you can just pass the values 10 times to that function and the operation will be executed. So this reduces the code length drastically and also the compilation time will be reduced drastically and the code performance will be improved exponentially. So with this, let us try to understand the advantages of functions in C programming. Advantages of functions are writing the same code repeatedly in program will be avoided, which is the example we discussed about. And after that, functions can be called any number of times in a program. According to the previous example, we had to call 10 times. We can also call multiple times, more than 10 also. And after that, tracking a program easily when it is divided into multiple functions. For example, if you divide your main program into multiple functions, then tracking it would be easy. For example, if you have designed a program for borrow mass function, then if you find a problem in multiplication operation, then you can directly enter into multiplication function and check where the error is. But if you did not follow the function type of programming, then it might be a difficult task for you to find where the error is. And coming into the last advantage, reusability is the main achievement of C functions. With this, let us come into the rules for using functions. The rules to be followed to use functions in C programming are as follows. Firstly, function declaration. A function is required to declare as global and the name of the function, parameters of the function, and return type of the function are required to be clearly specified. This says that the function should be globally declared. This means before you start your main program, you need to declare what are the functions you are going to use in your program. Followed by that, you have parameters and name of the functions and the return types, which means whatever the name you specify to your function should be clearly specified and it should be readable. And also, it must include the parameters, the values which you will be passing to the function, and the return type, which means if you are getting some value, for example, as we discussed before, if you're performing an addition operation, then it is sure that you'll be getting a result out of it. So, whatever the result or whatever the return type you're getting should be specified. Followed by that, you have the next rule which says function call. While calling the function from anywhere in the program, care should be taken that the data type in the argument list and the number of elements in the argument are matching. For example, you have defined an addition operation. So, for a basic addition operation, you might be having two operands. So, in the main function, if you are calling the addition operation, then it must be taken care that before calling the function, the operands in the main program are also equals to 2. It is not possible to have 3 variables in calling function and 2 variables in called function. This is an error. So that care should be taken. Followed by that, the next rule is function definition. After the function is declared, it is important that the function includes parameters declared, code segment, and the return type value. Just declaring a function globally doesn't mean that your function should work. To make your function work, you must also define it, which includes the parameters which you are going to use in it, and the code segment and the operation that you want to perform should be included, and also the return type value. Followed by this, we shall understand how to use functions. There are 4 different aspects of using functions in C programming. The first is function without arguments and without return value. In this case, you don't pass any arguments to the called function, and similarly from the called function end, you won't pass any values to the calling function. In the second aspect, function without arguments and with return value. In this particular type, the calling function will not provide any arguments to the called function, but the called function will return a value to the calling function. The third type of aspect is function with argument and without return value. In this case, the calling function will provide some arguments to the called function, but the called function will not return any value to the calling function. The last aspect is function with arguments and with return value. In this particular case, the calling function will provide some arguments to the called function, as well as the called function after executing the operation will provide a result to the calling function. Now, let us try to execute some examples to understand this in a much better way. Functions can be called in 2 ways, either by reference or either by value. Let us execute 2 types to understand this in a much better way. First, let us execute call by value. This particular example is based on call by value. So here, what you are basically doing is, you are actually calling a function by passing values. So, let us try to execute this program and see how does it work. As you can see, the program has been executed successfully and the output has been displayed here. So the value of x before calling the function is 100, and once after the function has been called through value, some operations have taken place in the function and the result is been given by the called function to the calling function, and the value of num is been changed from 100 to 200. And finally, the value of x is 100 after function is been called. Now, let us try to execute a program based on call by reference. As you can see, this particular example is based on call by reference, where the function will be called according to the addresses of the variables used in the program. As you can see, the outputs have been successfully generated and the values have been changed here since the addresses of the values have been accessed. So if you access the value of a variable through its address, then the values will be changed. And this kind of operations is oftenly risky. So if you're a fresher, then don't prefer to use values and access them through addresses. With this, let us move on to our next topic, which is based on data structures. Data structure can be defined as a collection of data values, the relationships among them, and the functions that can be applied onto the data. They can be classified as follows: primitive data structures or built-in data structures, and the second type is abstract data structures or user-defined data structures. Let us understand the data structures in a much better way, and what are the types of data structures present in C programming language and how are they supported. Let us see them. They can be classified also based on their characteristics. Before this, we classified them according to their nature, but here we can characterize them according to their characteristics. Firstly, the linear ones, and followed by that we have the non-linear data structures. The next are homogeneous, followed by that we have non-homogeneous, and static, and finally the dynamic data structures. Let us understand each one of them in a much better way and understand what exactly they are. Firstly, let us deal with linear data structures. A linear data structure stores its elements in an arranged linear sequence. Non-linear data structures. Non-linear data structures store the elements in a non-linear fashion. For example, tree and graph. Followed by that, we have homogeneous data structures. A homogeneous data structure stores the elements that are made up of the same data type. For example, array. The next are non-homogeneous data structures. Non-homogeneous data structures store the elements that are of different data types. For example, structures. Followed by that, we have static data structures. A static data structure are those structures whose size and the allocated memory is fixed and cannot be changed during runtime. For example, array. Followed by that, we have dynamic data structures, and the only difference between static data structures and the dynamic data structures is that you can change the memory size of the data structure in runtime. So the most famous example for dynamic data structures is linked list. Now, let us understand each one of these data structures in a more detailed and better way. As you can see, the data structures, according to the first description, are divided into primitive data structures and abstract data structures. The primitive data structures are character, float, integer, pointer, and the abstract data structures or the user-defined data structures are arrays, lists, files. And inside lists, you can find non-linear lists and linear lists. If it is a non-linear list, you can include stacks and queues. And if it is a linear list, then you can include trees and graphs. Now let us understand each one of them in a much better way. Firstly, let us discuss arrays. An array is defined as a collection of similar type of data stored in continuous memory locations. The array is the simplest data structure where each data element can be randomly accessed using its index number. There are three different types of arrays, namely one-dimensional, two-dimensional, and three-dimensional. Now you must be confused about continuous memory and index. I'll explain you each and everything in a more detailed way. Firstly, let us understand one-dimensional array. So, one-dimensional array can be defined as an array with single row and multiple columns. The elements in one-dimensional array can be accessed using index numbers. Now here we'll be understanding what is index number, what is continuous memory, what is one-dimensional memory through this example. So here, this is how a basic one-dimensional array looks like. This is how the memory will be arranged in the physical memory of a computer when you have declared an array. So the array what I have declared is having the size of 5, and the memory addresses or the index of the array is known as the address which is specified for each and every memory location. So the first memory location of the array is 0, and this 0 is called as the index number. So the index number followed by 0 is 1, and similarly 2, 3 and 4. So the fifth element is having the index number as 4. The index numbers for arrays always start from 0. Now let us try to add elements into this system. The first element is 10. So into the array system, the element 10 will be included. Similarly, let us try to add few more numbers into the array system. They are 20, 30, 40 and 50. According to the definition, the elements will be arranged in a continuous order. Followed by index 0, the next index 1 will store the next element, which is 20. And similarly 30, 40 and 50. So this is how one-dimensional arrays work. If you want to access any element through this one-dimensional array, index number is used here. Now let us discuss two-dimensional arrays. The two-dimensional array can be defined as the array of arrays. The two-dimensional arrays are organized as matrices which can be represented as the collection of rows and columns. The elements of the array access using intersection of coordinates. Let us understand this in a much better way through the next example. Here we have a two-dimensional array. So this is how a basic two-dimensional array looks like. It has 2 different rows and 5 different columns. So to access any particular array, you need to select the intersection. For example, if you want to access the element which is stored in second row, first column, then you have to access the array index array 1, 1, which is this one. And if you need to access the element stored in second row, fourth column, then you need to provide the address as 1, 4, which is this particular location. Now let us try to add elements into this array. The first element would be 10, which will be stored in the first row, first column. Similarly, let us add few more numbers, which are 20, 30, 40, 50, 60, 70, 80 and 90, and finally 100. Now as you can see, the elements will be stored in a continuous format, and this is how the elements look after when they are stored into the array. Now let us move on to multi-dimensional array. Multi-dimensional array is completely similar to the two-dimensional array. Only thing is, another dimension is added to the arrays. That is, it might be 3D or even multiple dimensions. A multi-dimensional array can be defined as an array of arrays. The 3D array is organized as 3D matrix, which can be represented as a collection of multiple rows and multiple columns. The elements of the array are accessed using the 3D intersection coordinates. With this, let us move on to our next topic, which is lists. Lists are linear data structures similar to that of arrays, but the only difference is that the elements are not saved in a sequential memory locations. So the types of linked lists are singly linked list, doubly linked list, and circular linked list. To understand linked lists, we can assume this. What happens in arrays is the elements are stored in a sequential manner. That is, a particular big block of memory will be reserved for the array. And that block of memory will be divided into the number of indices. For example, if you decide an array of 5 elements of integer data type, then a bigger block of memory will be selected and that will be divided into 5 elements. Each memory block will be having same size, integer size, which is 2 bytes or 4 bytes. But in case of linked lists, if you define a linked list of 5 elements, then the memory is not reserved. What happens is, you will be having a memory heap, out of which 5 blocks will be randomly selected. So each one of the block will be having its own address. For example, you can see the first block is having the address of 1011. Followed by that, the next block of memory has 1023, and similarly the last has 7328. So this is how the 5 random integer type of memory blocks are selected. And after that, the elements in your list will be added to each one of them. So the first element will be added to some random block of memory, which is the 10 has been added to the first block, so which is 1011 and 20 to 1023 and 30 to 3026 and 40 to 4537, and last one is added to the 73281. Did you see the change here? The 7328 is changed to null. So this is what describes the end of list. So what exactly happens here is, all the elements are given to one or the other memory block, and all the memory blocks are interconnected with each other. As you can see, the first element is 10, the second element is 20, the third element is 30, the fourth element is 40, and the fifth element is 50. So all of those are allocated to one or the other memory, and once after all the numbers are added to all the blocks, then each and every block is connected in a sequential order. In here, the first block is connected to the second block, and second connected to third, and third to fourth, and fourth to fifth. And once after the last block is reached, that block memory address will be changed from the existing memory to null. This indicates the end of linked list. So this is how it behaves like an array. So it has the starting and ending points, and the starting point is called as head and the ending point is called as tail, and all the elements are called as nodes. So this is how a basic linked list exists. So we have three types of linked list in C programming language, which are singly linked list, doubly linked list, and circular linked list. Don't worry, I will explain you each and every type of linked list in a much better way along with practical examples. So firstly, singly linked list, second is doubly linked list, and the third one is circular linked list. Firstly, we have the singly linked list. In singly linked list, we have head and tail. The first block will store the head element, and the next block of the head will store the address of the next connected node. Similarly, the next node will store the element and the other block will store the address of the upcoming node. This continues until the tail node is reached. Similarly, we have doubly linked list. The only difference between singly linked list and the doubly linked list is, in singly linked list, you can only traverse in one direction, that is from head to tail. But in doubly linked list, you can traverse in both the ways, from head to tail and tail to head. This is possible because the head stores the element, along with it has two more blocks where one of the block will store the null element in the head and the other will store the address of the upcoming node. And when you come to the second node, you have two address blocks. One address block will store the address of the upcoming node and the other address block will store the element of the previous node. This happens until the tail node is reached. Similarly, we have circular linked list. Circular linked list is completely similar to the singly linked list. But the only difference is that the tail node will not have null element. Instead, it will store the address of head block or head node. So that's how it will be connected back to the head and the complete list will become a circular linked list. Now, we shall execute the elements based on arrays, single one-dimensional array, two-dimensional array, and coming into list, we shall execute singly linked list, doubly linked list, and circular linked list. Firstly, we shall execute one-dimensional array example. As you can see, this particular example is based on one-dimensional array, and I have provided the size of array as 3, which means it can store 4 elements. The index of array starts from 0. As you can see, I have stored the employee IDs of 4 different employees in one single dimensional array. Now, we shall try to execute an example for two-dimensional array. This particular example is based on two-dimensional array, which is having 2 different for loops. One is the external for loop, and inside that external for loop, we have the internal for loops. This is repeated for twice here. Now, let us try to execute this program and see how does the two-dimensional array looks like. The two-dimensional array must look like a matrix. Now you can see the program has been successfully executed and it is asking the values. Now let us include the values. First 1, second we shall include 2. Similarly, let me follow it. As you can see, the two-dimensional elements have been printed here. There is some problem in print statement. I think I have missed the escape sequence, which is backslash. Now let us re-execute the program again. You can see the elements printed in matrix format now. This is how the output looks like. Let us execute examples for linked lists. The first example will be based on singly linked list. As you can see, this particular example is based on singly linked list, and we can find the head elements as well as the tail elements, including all the nodes in between. You can see the program has been successfully executed and it is showing the head element as 100 and the tail element as 600, which is described by the null pointer which is located at the tail part. Now let us try to execute an example for doubly linked list. You can see this particular example is based on doubly linked list, and in here I am defining head and the last tail and the current node. And this is the structure of node what we have defined here, which includes the data and previous and next addresses, which are the pointer variables. And followed by that, we have the link definition here, the head link, and after that we have the current link. And lastly, we are trying to insert elements 10, 20, 30, 40, 50 and 60 into the linked list. Now let us try to execute this program. You can see the program has been successfully executed and the doubly linked list is being described here. You can see the head node which is 10, and followed by that you have the next node which is 20, 30, 40, 50 and 60. Each of the other nodes are connected to each other, and finally you have the head node which is interconnected to it. Now let us try to execute the third type of linked list, which is circular linked lists. So this particular example is completely similar to the previous one, where we have the elements interconnected with each other and the last element will connect with the head. As you can see, the elements have been successfully displayed here, and it is a singly linked list. As I said before, the only difference is that the last element, which is the tail element, gets connected with the head, which makes it a circular linked list. Let us move on to our next topic, which is stack. So what is stack? Stack is a linear data structure which follows a particular order in which the operations are performed. The order might be either LIFO, which is last in first out, or first in last out, or called as FILO. Stack is completely similar to array, but the only difference is if we want to access stack, then it should be last in first out or first in last out. Let us see this example to understand how does it work. Firstly, let me add the first element, which is 10, into my stack. So 10 will be added to the first location, my stack 0. Followed by that, let us include few more elements, which are 20, 30, 40 and 50. So these are added to the respective locations. So 20 is added to 1, 30 to index 2, 40 to index 3 and 50 to index 4. Now if I want to access the elements in stack, I cannot randomly access it. All I need to do is to access the elements one after the other, which is last in first out or first in last out. According to the first in last out or last in first out, we have 50 as the last in element, and it should be the first out element also. So first 50 is popped out, and after that 40 is popped out, and 30 is popped out, 20 and 10. So this is how the elements are pushed and popped in a stack. So when you're placing an element into the stack, it is called as push, and when you're putting out the elements out of the stack, it is called as pop. The elements 10, 20, 30, 40 and 50 were pushed into the stack, and using the last in first out principle, we have popped out 50, 40, 30, 20 and 10. Now let us try to execute an example to understand this in a much better way. As you can see, this particular example is based on stack, and here we will be pushing few elements into the stack, and later we will be popping the elements. As you can see, this particular main program is having a push function where I'll be pushing 11, 12 and 33 elements into the stack, and I'll also be popping out them in the same way using the first in last out principle. Now let us execute this program. As you can see, the program has been successfully executed, and the elements 11, 12 and 33 are pushed, and using the last in first out principle, we have popped the element 33 from the stack. Now, let us move on to our next topic, which is queue. Queue is completely similar to stack, but the only difference is it follows FIFO, which is first in, first out. Now, the definition says that a queue is a linear structure which follows a particular order in which operations can be performed. The order is first in, first out. Let us understand the terminology of queue. Similar to stack, the elements are pushed into the queue. First 10, and followed by that we are going to push the elements 20, 30, 40 and 50 into the queue. And unlike the same way which we pop the elements in stack, we are going to dequeue the elements from queue in a reverse order, which is first in, first out. So according to this principle, 10 was the element which was first pushed into the queue. Now 10 must be the element which will be first pushed out or popped out or dequeued from the queue. As you can see, 10 is been dequeued from queue, followed by that 20 will be the next element which will be dequeued from queue, and next 30, and similarly 40 and 50. So this is how the queue works. First in, first out. Let us execute a program to understand queues in a much better way. We will be enqueuing the elements 1, 2, 3, 4, 5 and 6, and after that we'll be displaying the queue, and after that we'll be executing a dequeue function to dequeue the elements inside the queue. Now let us run this program and see how does it work. Don't worry about the code, I'll be linking that with the description. As you can see, the elements which are inserted are 1, 2, 3, 4, 5, and once after the queue is full, the elements have been displayed here and one element was deleted. So the first element 1 is deleted, and after that the elements present in the queue are 2, 3 and 4 and 5. Let us move on to our next topic, which is graphs. Graph is defined as a data structure that is represented in a graphical format using nodes and edges. A graph in C language is commonly represented in two formats. Firstly, adjacency matrix and adjacency lists. Now let us discuss the first type of graphs. You can see this is a graph. And here we have the nodes, which are 0, 1, 2, 3 and 4. And the lines which are connecting 0 and 1 are called as edges. So we have edges for 0 to 1, 0 to 4. And similarly we have edges from 1 to 4, 1 to 3 and 1 to 2. And in this way, all the elements are interconnected to each other. Few are connected and few may not. Now let us describe the graphs using adjacency matrix. As you can see, this is adjacency matrix and the links between the nodes have been described using adjacency matrix. For example, 0 to 0. If there is a link existing between 0 to 0, then it will be specified as 1. If there is no link between 0 to 0, then it should be specified as 0. So 0 to 0 we don't have any edge, so it must be represented as 0. 0 to 1 we do have an edge, so it should be represented as 1. And 0 to 3 you might think there is an edge, but there is no direct edge. So it is 0. And similarly we don't have a direct connection to 2, so it is also 0. Now let us see the adjacency matrix and understand this in a much better way. So to 0 to 0 there was no edge, so it is described as 0. And 0 to 1 there was an edge, so it is described as 1. And 0 to 2 we don't have an edge, direct edge, so it is described as 0. Similarly to 3 and to 0 to 4 we do have an edge, so it is described as 1. So this is how adjacency matrix works. And similarly the adjacency list. Adjacency list is nothing but a linked list which will show the links between the nodes. So 0 to 1 we had a link and 0 to 4 we also had a link. But once after 0 is connected to 1 and 4, 0 is not connected to any of the other elements. So the end of adjacency list is finished here. And followed by that the next node is 1. So 1 is connected to 0, 1 is also connected to 4, 1 is connected to 2, 1 is connected to 3, but 1 is not connected to 1. So we have an end of the adjacency list here. And similarly we have 2, 3 and 4. So this is how adjacency list works. Next we have directed graphs. The only difference between a normal undirected graph and directed graph is the direction. So here we describe the connection between the nodes based on the direction. So we do have a connection between 3 to 2, but we don't have a connection from 2 to 3. Because the direction is outwards from 3 to inward 2. So this is how you need to consider the graph and you have to design the adjacency matrix and adjacency list. So according to this, we don't have a link between 2 to 3, but we have a link between 3 to 2. 2 is directing to 3? No, we have 0. But 3 is directing to 2? Yes, we have 1. Similarly, we have the adjacency list. Here, 0 is connected to 1, 1 is connected to 2, and 2 is connected to 1 and 0, and 3 is connected to 2, 4 to 5, and 5 to 4. Now, let us understand weighted directed graphs. Weighted directed graphs are completely similar to directed graphs. The only difference is that we have certain weights or certain costs for the traversal of the nodes from one to another on their edges. So, according to the adjacency matrix, there is no change. But according to the adjacency list, we have a little change which includes the cost or the weight of the traversal of nodes from one to another. Followed by this, we have files. Basic file handling techniques in C programming provide the basic functionalities that user can perform against files in the systems. Now, let us understand this in a much better way. So, the following functionalities are the basic file handling techniques. To create a new file, fopen with attributes A+, W or W++. We shall understand this in detail in the next upcoming concepts. Opening files, we have to use the fopen function, and reading files, we can use the functions fscanf or fgetc. And to write in a particular file, we can either use fprintf or fputs. And followed by that, to moving to a specific location in a file, we can either use fseek or rewind. And finally, to close a file, we have to use the function fclose. Don't worry, I'll explain each one of these functions using a specific program. In short, fopen is used to open a file, fclose is used to close a file, fgets is used to read a file, and fprint is used to write into a file. Let us execute programs based on all of these three factors. Let us try to create a file and write some text into that file. So here I am trying to create a file by the name edureka.c, and the message I'll be writing into that file would be Edureka Happy Learning. As you can see, the program has been successfully executed and the file has been created, and the message which I wanted to print has been successfully written into the file, which is Edureka Happy Learning. Let us try to execute a different program where we have to just read the content which is present in the file. As you can see, this particular program has been designed to read the contents present in that particular file. Let us now try to run this program. As you can see, the program has been successfully executed and it is reading the file with some message which says it is missing semicolon. Okay, let me include a semicolon here. Let me try to run this program again. If the error shows again, there might be some problem with the compiler. The compiler is reading the message. Basically, if you execute this program in an actual C editor, which is Turbo C++ or C, it should not throw an error. It is reading the file. So now let us move on to our next section, which defines the functions of R, W, A, and R+, W+, and A+. So R searches a file. If the file is opened successfully using fopen function, then it loads the particular file and sets a pointer to it. And that pointer will be specified to the first character which is starting in the particular file. Followed by that we have W. W just searches for a file. If the file exists, then the contents will be overwritten. If the file does not exist, then a new file will be created and a null value will be returned if it is unable to open that particular file. Next is A. A searches for the file. If the file is opened successfully, then fopen loads it to the memory and sets up a pointer, and that points to the last character of the file. If the file doesn't exist, then a new file is created, and if a file doesn't open, then it returns a null value. Now, let us go into R+, W+, and A+. R+ searches a file. If it is opened successfully, then fopen loads it up into the memory and sets up a pointer which points to the first character in it. If it is not open, then R+ will return null pointer if it is unable to open it. Followed by that we have W+. W+ searches for the file. If the file is existing, then the contents of that particular file are overwritten, and if the file doesn't exist, then it creates a new file. And in case if it is not able to open it, it will return a null pointer. Similarly, A+. A+ searches a file. If the file is opened successfully, then it loads into the memory and sets the pointer to the last character of the existing file. If it doesn't exist, then a new file is created, and finally, if it is not able to open the file, then it returns a null value. Next, we have strings. The string is defined as a one-dimensional array of characters terminated by a null character. The character array or the string is used to store text such as word or sentences. Each character in the array occupies 1 byte of memory, and the last character must be 0. So as discussed before, strings are completely similar to arrays. The elements are stored in sequential memory, similar to array. But the only difference is that strings include a null character at the end of the array just to convey the compiler that it is the end of the string. So strings are basically two types, which are character arrays or string literals. Now we have some basic operations which will be applied on strings. The most basic operations which we apply on strings are string length, which will return the length of the string. Followed by that we have string copy, which copies the string from source to destination, and string cat, which is used to join two or more strings. And after that we have string comparison, which compares the given two strings. After that we have string reverse, which reverses the given string. Followed by that we have string lower and string upper, which converts the case of the string. For example, if we use string lower, then the uppercase of the string will be converted into the lowercase, and similarly string upper will convert the lowercase characters into the uppercase characters. Now let us use Eclipse. So this particular example is based on string length operation, where I have provided the string edureka and I am trying to find out the length of the string. Now let's run this program. As you can see, the length of the string edureka is found to be 7. Similarly, let us also execute other programs based on other string functions. The next string function is string copy, where I'll be trying to copy the string edureka from string 1 to string 2 and see if the data is being printed into the string 2 or not. Let us try to execute this program. As you can see, the data from string 1 is copied into the string 2 and the data inside string 2 is being successfully displayed here. Followed by this, we shall also execute an example for string comparison. In this particular program, I'll be comparing the string 1 with string 2. Let us execute this program. As you can see, the program has been successfully executed. And now let me type in the string 1, which is Edureka. Similarly, let me type in the string 2 in the same way how the string 1 is being declared, which is Edureka. Now, let us compare if string 1 is equal to string 2 or not. As you can see, the strings are declared to be equal. Now, let us try to execute a program based on string concatenation. In this particular program, I'll be concatenating two different strings. As you can see, I have provided string 1 as hello and string 2 as world. So, according to my function, I should be concatenating both the strings, which is hello and world. As you can see, the program is being successfully executed and both the strings are concatenated into one single word, which is string hello world. Followed by this, we shall also execute a program for string reverse function. In this particular example, I'll be writing the text happy learning into the string and I'll be trying to reverse this particular string. Let us execute this program. As you can see, the string before reversing is happy learning and string after reversing is this. Let us try to execute an example based on string lawyer, where a particular string in uppercase will be converted into lowercase. Now let me write a string in uppercase. I have written Edureka in uppercase. Now let us convert it into lowercase. So as you can see, the data has been displayed as Edureka in lowercase. Similarly, let us try to execute a program based on string uppercase. As you can see, the program has been successfully compiled. Now let me write some text in lowercase. Edureka has been written in lowercase and according to the output, Edureka text is been converted into uppercase. Now with this, let us get into our next topic, which is about structures and unions. Firstly, let us deal with structures. A structure is a user-defined data type available in C language that allows to combine the data items of different data types together. Structures are used to represent a record. Struct is a keyword that is used to declare structures. Basically, structure is a data type. For example, if you consider array or lists, you can only store a specific data type of elements because array will not allow you to store different elements of different data types. But what if you had to store a database of a school which has different data types? For example, roll number will be integer, marks will be float, and name will be string. In that case, you cannot use arrays or you cannot even use lists. The only available option is structure or either a union. What structure basically does is, it is capable enough to store the values of different data types. For example, here I am considering school. I have defined a structure using the keyword struct and the name of my structure is school, inside which I have declared ID of a student using integer data type and name of the student using string data type and percentage of the student using float data type. Now to understand structures in a much better way, let us execute a practical program. Now let us use an online compiler to compile our code. So in this particular example, I am writing the roll number, name and marks of a particular student. So let us execute this code. As you can see, the code has been successfully compiled and it is asking me for input the name, roll number and percentage of the student. Let me write a random name to the student, Raj, and his roll number will be 123. Followed by that, let us include his percentage, which will be 75.4. As you can see, the data has been successfully inputted for the first student. Now as we have defined the for loop, which will run for 3 times, so let us also include another student's details here. Name as Ram and his roll number will be 124 and percentage will be around 60. Now let us enter the value for third student. As you can see, the details of all the 3 students are being displayed here. So with this, let us move into our next topic, which is union. A union is a special data type available in C language that allows storing different data types in same memory location. Union is the keyword used to declare union. So you might be confused about structure and union here. Why are two different data structures defined for performing one single operation? Don't worry, there are few differences between union and structure which we will discuss after this topic. So let us execute an example to understand union in a much better way. We shall consider the example of employees. As you can see, the code has been successfully compiled and the data of the employee has been displayed here. The ID of employee is 18518774450 and the name is Larn C. With this, let us move on to the differences between structure and union. The key differences between structure and union are keyword, memory, change of value, access to data, and initialization. The keyword to declare structure is struct and the keyword to declare union is union. After that, the memory. In structure, each member has unique memory space. For example, ID has a unique memory space, name has its own unique space, and followed by that, even the percentage has its own unique space. When it comes to union, a whole complete block of memory will be declared for union, and all the data members will be sharing that allocated memory. When it comes to the next parameter, it is change of value. Changing the value of one member in structure will not affect the others. But in case of unions, changing the value of one member will definitely affect the others because they are sharing one common memory. After that, access to data. All members can be accessed at one single time if you are using a structure. But when it comes to union, you have to access one member at one single time. You cannot access all the members at one single time. And the last parameter is initialization. All the members of the structure can be initialized at once, but when it comes to union, the only first member of the union can be initialized. So these were the few major differences between structure and union. Let us move into the next topic, which is data segments. So what are data segments? Data segments are divided into 4 different types. They are data area, code area, heap area, and stack area. What are these? Let us discuss each one of them in detail. Firstly, data area. Data area is permanent memory area. All static and external variables are stored in this data area. All variables which are stored in data area exist until the program exists. Followed by that, we have code memory area. Code memory area is only area which can be accessed by function pointers. The size of code area is completely fixed. Followed by that, we have the heap area. The heap area is used to store the data structures which are created by using dynamic memory allocation. We shall discuss about dynamic memory allocation and the functions available in dynamic memory allocation after this concept. So the size of heap area is variable and depends upon the free space in the memory. Followed by that, we have the stack area. Stack area is divided into 2 parts, namely initialize and non-initialize. Initialized variables are given priority than non-initialized variables. So with this, we shall move on to our next important topic, which is dynamic memory allocation. So what is dynamic memory allocation? Dynamic memory allocation is defined as a procedure in which the size of the data structure is changed during the runtime. There are 4 library functions provided by C in standard library.h header, and this facilitates the dynamic memory allocation. Now let us discuss the dynamic memory allocation functions. Those are malloc, calloc, realloc, and free. Firstly, malloc. Malloc or memory allocation method is used to dynamically allocate a single large block of memory with the specified size. It returns a pointer type void which can be cast into a pointer of any form. Followed by that, we have calloc. Calloc or continuous memory allocation method is used to dynamically allocate a specific number of blocks of memory of specified types. It includes each block with a default value of 0. The only difference between malloc and calloc is malloc, after allocating a block of memory, will not allocate with a default value of 0. Instead, a junk value is stored there. But in calloc, it will allocate each and every memory block with a default value as 0. Followed by that, we have realloc. Realloc or reallocation is a method used to dynamically change the memory of previously allocated memory. If the memory is previously allocated with help of malloc or calloc, and in case if it is insufficient, then you can reuse realloc and increase the memory size. Realloc is used to dynamically reallocate memory. Followed by that, we have free method. Free method is most important method. Don't ever forget to use free method when you are allocating memory using dynamic memory allocation, because free method deallocates the memory. The memory allocated using the functions malloc and calloc are not deallocated on their own. Hence, free method is used whenever the dynamic memory allocation takes place. It helps to reduce the wastage of memory by freeing it. Now, let us execute programs based on malloc, calloc, realloc, and free. Now, let us execute this program based on malloc. So this particular example is based on malloc. We are using malloc function here, and the data type we have chosen is integer. Now, let us execute this program. As you can see, the number of elements we have chosen are 5, and the memory has been allocated using malloc, and the elements of the array are 1, 2, 3, 4, and 5. Similarly, let us execute a program based on calloc. As you can see, the memory has been successfully allocated using calloc function, and the elements are 1, 2, 3, 4, and 5. Let us execute realloc. Now you can see the memory has been reallocated using realloc. Usually, using malloc and calloc, we have created elements only for 5 elements, which were 1, 2, 3, and 4, and 5. We needed extra space for 6, 7, 8, and 9, and 10. So we have created that extra space using realloc here. Now let us use free method to free all the memory which we have created using calloc, malloc, and realloc functions. Now you can see the memory will be freed using free method. As you can see, the output says that the number of elements were 5, memory successfully allocated using malloc, and malloc memory is been successfully freed. Similarly, calloc is also been freed. Now that we have completed dynamic memory allocation concepts, let us now move on to sorting algorithms. Sorting algorithms are used to arrange the elements of an array in a particular order. The order might be either ascending order or descending order. Now, C programming language has n number of sorting algorithms, out of which we have some primary important basic algorithms which we will be discussing now. Basically, what is a sorting algorithm? A sorting algorithm is used to rearrange a given array or list elements according to the comparison operator on the elements. The comparison operator is used to decide the new order of elements in respect to the data structure. As we have discussed earlier, the sorting algorithms are used to arrange the elements of array or list in a particular order, either ascending or descending. It is based on a condition which you specify. Now, with this, let us move on to the sorting algorithms that we will be discussing today. Firstly, bubble sort, and followed by that, we will discuss about insertion sort, and finally, selection sort. So first, the bubble sort. Bubble sort is the most basic and brute force method of arranging the elements of an array. Now, what happens in bubble sort? In bubble sort, we consider the first element of the array to be the smallest of all the other elements. And this small element will be compared by the next following element. If the following element is smaller than the first element, they will be swapped. Followed by that, the second element of the array will be compared with the third, and third with fourth, and so on. Let us now understand this through this simple example. As you can see in this particular example, we have an array of 5 elements. In the first iteration, the first element, which is -2, will be compared with the second element, 45. If the second element is smaller than the first element, then they will be swapped. In this particular algorithm, we are going to arrange the elements in ascending order. So, the smaller element will be located in the first place. Firstly, you can see -2 is smaller than 45, so in the comparison, -2 will be left in the first position. And in the second iteration, you can see 45 will be compared with the third element, which is 0. So here, 0 happens to be a smaller element than 45, so they both will be swapped here. Followed by that, in the third iteration, we will be comparing 11 with the element 45. 11 happens to be the smaller element than 45, so they will be swapped again. And in the last iteration, 45 will be compared with -9, and -9 happens to be the smaller element than 45, so they will be swapped. So this was the first cycle. So in this cycle, the elements are arranged to a particular extent, but not completely. So we will follow the next cycle, where the elements will be compared again from the starting. In the starting iteration, -2 will be compared with 0. As you can see, -2 happens to be smaller than 0, so no changes in the positions of the elements. Followed by that, 0 will be compared with 11, and 11 happens to be bigger than 0, so no change in that as well. In the next iteration, 11 will be compared with minus 9, and minus 9 happens to be a smaller element compared to 11, so they both will be swapped. And in the last iteration, 11 will be compared with 45, where 11 will be the smallest, so no change in their positions. And now we will see the third cycle. In the third cycle, minus 2 will be compared with 0 in the first iteration, followed by that 0 will be again compared with minus 9. Minus 9 happens to be smaller than 0, so they both will be swapped. And in the third iteration, 0 will be compared with 11 and the positions will not be changed because 0 is less than 11. And in the fourth iteration, 11 will be compared with 45, where 45 happens to be the biggest number than 11, so no change in the position. So in the last cycle, minus 2 will be compared with minus 9, and minus 9 happens to be a smaller element compared to minus 2, so they both will be swapped. And in the last iteration, you can see that minus 9 is in the correct position, that is the smallest position, happening to be the first of the array, and followed by that we have the second position with minus 2, and third position we have 0, fourth, 11, and finally 45. Hence the array is been sorted here. So this is how bubble sort algorithm works. Now let us see a practical example so that we can understand this algorithm in a much better way. So this particular example is based on bubble sort. We are going to arrange each and every element in a particular position based on ascending order. This is the same array that we have considered in our previous example, which has the elements minus 2, 45, 0, 11, and minus 9. Now let us run this program and see the output. As you can see, the program got successfully executed and the elements of the array are in ascending order. And the ascending order is being achieved through bubble sort algorithm. Followed by this, let us move on to our next sorting algorithm, which happens to be the insertion sort. Insertion sort is also completely similar to bubble sort, but the only difference is that we presume that the first element of the array is already sorted. So in this case, we consider the first element of the array, which is 9, is already sorted. Followed by that, we have 5. So we will take 5 as the key. So here, we have considered 5 as the key, and now we compare 5 with 9. So in comparison, if 5 happens to be the smaller number than the presumed arranged element, which is 9, then they both will be swapped. We can see that 5 is already smaller than 9. So what we do is, we replace 9 with 5 and 5 with 9. So in the next iteration, we will consider the first two elements to be sorted and we will consider the third element as the key. Now we will take 1 in the position of key and now we'll compare the key with the first two elements, which are 5 and 9. So we can see that 1 happens to be smaller than 5 and 9. And inside we can see that 5 happens to be smaller than 9. So we send 9 to the position of 1 and 5 to the position of 9 and 1 to the position of 5. So this is how it happened. Firstly, we compare 1 with 5 and 1 with 9. And we find that 1 is smaller than 5 and 9. And later we compare 9 and 5. So we find that 5 is smaller than 9. The bigger number will be sent to the place of the key. And the next following number will be sent to the position of the earlier number. And the smallest key will be sent to the first position. Followed by this, we have the next iteration where we'll consider 4 as the key. So 4 will be taken into the position of key. Now 4 will be compared with the previous elements, which are 1, 5 and 9. So we can see that 4 is greater than the first position 1. So we will not make any changes to the first position. Followed by that, we will compare 4 with 5. So here we can see that 4 is smaller than 5. Followed by that, we'll compare 4 with 9. We can see that 9 is bigger than 4. What we will do is, now we'll compare the other two elements in the array, which are 5 and 9. 5 is smaller than 9. So we will send 9 to the key position, which is 4. So followed by that, we will send 5 to 9th position as shown in the next iteration. And now, the position where 5 element was removed will be empty, and inside that position we will send 4. And that's how the array will be sorted here. You can see 1, 4, 5 and 9. And in the next cycle, we will take the element 3 as the key and we'll compare with the other elements. As you can see, 3 is taken into the key position and now 3 will be compared with all the elements in the array. As you can see, 3 is compared with 1 and you can see 1 is already arranged and 3 is compared with 4 and you can see 4 is bigger than 3. Now we will compare the other elements with 3, and 3 is compared with 5, and it happens to be 3 is smaller than 5, followed by that 3 is also smaller than 9. Now the elements inside the arrays are compared. Now the number 9 happens to be the biggest one, so 9 will be sent to the key position, followed by that 5 will be sent to the ninth position, and 4 will be sent to the fifth position. And 3 will be in the position of 4, which will be vacant after 4 is transferred to the fifth position. As you can see, now the array is completely sorted. In the ascending order, where 1 is the smallest number, followed by that we have 3, next is 4, next is 5, and lastly we have 9. Now, let us see a practical example to understand insertion sort in a much better way. Let us consider the same array what we have discussed here. So this particular example is based on insertion sort, and we will be considering the same array what we have discussed in our earlier example, which is 9, 5, 1, and 4 and 3. Let us execute this program and see if the array will be sorted in ascending order according to insertion sort or not. As you can see, the program has been successfully compiled, and we obtain the same result what we discussed before, which is 1, 3, 4, 5 and 9. Now with this, let us move on to our last algorithm, which is selection sort algorithm. Selection sort happens to be a little different from the other two algorithms. Here, we actually compare all the elements with each other, and we come to an end with the smallest element, and we declare that particular smallest element as minimum, and we will replace that element to the first position. And after that we come to the next cycle, where we swap the second smallest element in the second position of the array. Now let us understand this through this particular example, where we have considered an array which has 5 elements, namely 20, 12, 10, 15 and 2. Now we will compare the elements present in the array. As you can see, the first element happens to be 20. We will assign 20 as minimum in the first cycle. Now what we do is, we'll compare 20 with 12, and we will find out which is the minimum. 12 happens to be the minimum number when compared with 20. So 12 is now the new minimum element. Now 12 will be compared with the next following element, which is 10. We can see that 10 is the next minimum element found in the array, and now 10 is the new minimum element declared. Followed by that, we will compare the next element with the minimum, which is 15. 15 is greater than 10, so there is no change. Next, we will compare 10 with the last element, which is 2. Now we find that 2 is the smallest element compared to 10. So the last minimum element finally obtained is 2. So what we do here is, we will swap 2 with the first position, which is 20. As you can see, now the element 20 is been replaced by 2. So 2 is the first element sorted in selection sort algorithm. Before moving into the second cycle, let us have a small acknowledgement of the first cycle. So this is how the comparison happened. Firstly, we considered 20 was the minimum number, but 12 happened to be the minimum number. Followed by that, we got our next minimum number, which is 10. And lastly, we got 2, our minimum number. And finally, the array got sorted with the first element placing 2 in the first position. Followed by that, now we shall move to the next cycle. In the next cycle, we can see the first position of the array 2 is been successfully sorted. Now we shall consider 12 to be the minimum number. So we consider the minimum number to be 10. Now 10 will be compared with the next following number, which is 15. And we find that 10 is already smaller than 15, so there will be no change in the position. Followed by that, we have 10 and 20. So 10 happens to be the smaller number when we compare with 20. So there is no change in the position. So now what we do is, we shall swap the position of 12 with 10, making that the next smallest element in the array. With this, we finish the second cycle. Now we shall move to the third cycle, where we will consider the following element after 10, which is 12, to be the minimum element, and we will compare with the other following elements, which are 15 and 20. As you can see, we have considered 12 to be the minimum number, and we compare with 15, and we obtain 12 is smaller than 15, so there is no change in the position. In the next iteration, we compare 12 with 20, and we find that 12 is smaller number compared to 20, so there is no change in the position again. So we find that the array has been already sorted for this cycle, and we will move on to the next cycle, where we will make 15 as our minimum element, and we will compare 15 with the following element, which is 20. So here you can see that we have made 15 as our next minimum element, and now we are comparing with the element 20. And we find that 15 is already smaller than 20, so there is no change in the positioning. And finally, we obtain the sorted array. Now, let us execute a practical example to understand selection sort algorithm in a much better way. We shall consider the same array in that particular example as well. Now, this particular example is based on selection sort algorithm, and we have taken the same elements which we have discussed in the earlier example, which are 20, 12, 10, 15 and 2. If the elements will be arranged in ascending order according to selection sort algorithm or not. As you can see, the program got successfully executed and the elements of the array have been sorted in ascending order based on selection sort algorithm, and the result what we have obtained is completely similar to the result we have discussed before, which is 2, 10, 12, 15 and 20. With this, we come to an end of this tutorial, and I hope this tutorial was useful. If you have any doubts or any queries, and if you need the code for any of the examples that we executed in this particular tutorial, you can write to us in the comment section below, and we will reply you at the earliest. Till then, thank you and happy learning.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!